Hello students, in this video I am going to explain some of the multiple choice questions from the first chapter, some basic concepts of chemistry, so which will be helping you to solve competitive exams like CET, NEET or JEE. First question, few quantities with their units are listed below. Mark the units which are not correctly matched. Density kg per meter cube, velocity of light meter per second, Planck's constant Joule inverse second inverse, acceleration meter per second square, force kg meter. So here quantities with their units are given. We have to choose the one which is not correctly matched. So let us see one by one. First one, density kg per meter cube. It is the correct match, correct unit. Velocity of light, you know that it is meter per second. So correct one. Planck's constant Joule inverse second inverse. This is not correct. So Planck's constant is having unit of Joule second. Acceleration meter per second square, correct one. Force kg meter. So this is not correct. Force is having a unit of Newton. So here not correctly matched are third and fifth. So in option you can see C option. Okay. So third and 5 is the answer. Second question, how many significant figures are present in this number? So you have to calculate the number of significant figures present in this number. So this 0 which is present left to decimal point is said to be non-significant. So this 0 after decimal point which is present left to non-zero digit is said to be non-significant, and this 1 is significant because it is non-zero digit. After 1 this 0 is present, right to 1, right to non-zero digit 0 is present, so this is also significant. This digit also significant. So after non-zero digit, two zeros are present. So these zeros are also significant. So total number of significant figures are 1, 2, 3, 4, 5. So the answer is 5. Next question, third one. How many seconds are there in 3 days? Options are given here. So answer is option A. How? Solution. So 1 day is nothing but it is equal to 24 hours. So here they had asked 3 days. So into 3, 1 hour means 60 minutes. 1 minute means you know that 60 seconds. Hence all you have to multiply 3 into 24 into 60 into 60. So you will be getting this answer. So this answer is option A. Fourth question, the reference standard used for defining atomic mass is hydrogen, carbon 12, carbon 13, carbon 14. So you know the definition of atomic mass. So at 1 atomic mass is equal to 1 by 12 the carbon 12 isotope. Hence by the definition I can say reference standard is carbon 12. Fifth question, 2 moles of glucose is dissolved in 30 moles of water. The mole fraction of glucose solution is. So options are given different values. So you have to calculate here mole fraction of glucose. So the formula is mole fraction of glucose is equal to number of moles of glucose divided by number of moles of glucose plus number of moles of water. So if you substitute 2 divided by 2 plus 30, that is equal to 2 divided by 32. So the answer will be 0.0625. If you calculate, you will be getting this answer. Next question. The number of oxygen atom present in 1 mole of oxalic acid dihydrate is 6 into 10 to the power 23, 6.022 into 10 to the power 34, 7.22 into 10 to the power 23, 36.13 into 10 to the power 23. So the answer is D, 36.13 into 10 to the power 23. How you will get this answer? So I'll show the solution. First you have to write the formula of oxalic acid dihydrate, that is COOH twice dot 2H2O. This is the formula of oxalic acid dihydrate. Next we have to count the total number of oxygen atoms. So here it is 6. So 1, 2, 2 into 2, 4, 4 plus 2 equal to 6. So 1 mole of oxalic acid consists of Avogadro number of particles. So 1 mole of oxalic acid is having Avogadro number of particles, that means 6.023 into 10 to the power 23. Hence here 6 atoms of oxygen is present. So 6 into 6.023 into 10 to the power 23. So the answer is 36.13 into 10 to the power 23. Seventh question. 1 gram of magnesium is burnt in a closed vessel containing 0.7 gram of oxygen. Which reactant is limiting reagent and how much of the excess reagent will left? So options are given. A. O2 is a limiting reagent and magnesium is excess by 0.25. Magnesium is a limiting reagent and it is excess by 0.5. Oxygen is a limiting reagent and is in excess by 0.25 gram. O2 is a limiting reagent and Mg is in excess by 0.75 gram. So you know that by the definition of limiting reagent, so these are the reagents which are present during a reaction. So this limiting reagent will limit the formation of product. So these limiting reagents are nothing but reactant which get completely consumed during a reaction and further product formation will be limited. Okay. So here 1 gram of Mg is present, 0.75 gram of O2 is present. So 0.75 gram of O2 will react with 0.75 gram of Mg and remaining Mg is 0.25 gram. So that means here limiting reagent is O2 and Mg is present in excess and remaining portion of Mg is 0.25 gram. So it is matching with the option A. So answer is O2 is a limiting reagent and magnesium is excess by 0.25 gram. Question number 8. Dissolving 120 gram of urea having molecular weight of 60 in 1000 gram of water gave a solution of density 1.15 gram per milliliter. The molarity of the solution is option A 1.78 molar, option B 2.00 molar, option C 2.05 molar, option D 2.22 molar. The correct choice is C 2.05 molar. How we can calculate? So solution is, for calculating the molarity of the solution, first we require to know two things. One is number of moles of urea and total volume of the solution. Because you know that what is the formula of molarity? So molarity is equal to number of moles of the substance divided by total volume of the solution in a liter. So number of moles of urea can be calculated by using the formula of mass by molar mass. Always you remember that to calculate the number of moles of substance, you have to do mass by its molar mass. So here mass of the urea is 120, molar mass is 60. So So equal to 2. 2 is the number of moles of urea dissolved in a solution. Next you have to calculate second part, that is total volume of the solution. For that first you have to calculate total mass of the solution. So that is 120 plus 1000 here. So that is equal to 1120 gram. Next you have to convert total mass to the volume in liter. So how you can convert? You have to use this value, density value. You can use this one. So you know that density is equal to mass by volume. So rearrange the equation for volume. You require volume. So volume is equal to mass divided by density. Mass you calculated here in the previous step and density is given in the question. So substitute two values, you will get answer in ml. So this ml, milliliter, is converting into liter. So it becomes 0.974 liter. Then you use the molarity formula. Number of moles of the solution, moles of the substance divided by total volume of the solution. 2 divided by 0.974, answer is 2.05. Hence the correct option is C. So ninth question, a gaseous hydrocarbon gives upon combustion 0.72 gram of water and 3.08 gram of carbon dioxide. The empirical formula of hydrocarbon is, options are given, option A C3H4, option B C6H5, option C C7H8, option D C2H4. So the correct choice is C7H8. So how you can calculate this one? I will show. Solution. So first you have to consider the general equation for the combustion of hydrocarbon. So this is the general equation for the combustion of any hydrocarbon. So that is CxH5 plus Y by X plus Y by 4 O2 gives X number of carbon dioxide and Y by 2 number of water. So here you have to calculate the value of X and Y. So that will give rise to formula, empirical formula of hydrocarbon. So to calculate that one, first you have to calculate number of moles of carbon dioxide produced. So that can be calculated by doing mass by molar mass. So mass is 3.08, molar mass is 44. So molar mass of carbon dioxide can be calculated by adding atomic masses of carbon and 2 oxygen. So atomic mass of carbon is 12 plus 2 into 16. So 32. So 32 plus 12, it is equal to 44. So you will get 0.07 as the number of moles of carbon dioxide produced. Next you have to similarly calculate the number of moles of water produced by doing mass by molar mass. So mass is 0.72 and molar mass is 18. So here also can be calculated by doing adding atomic mass of hydrogen and water. So hydrogen 2 plus oxygen is 16. 16 plus 2 equal to 18 is the molecular mass of water. So it becomes equal to 0.04. Next you do x by y by 2. So x is 0.07, y by 2 is 0.04. You will get an answer of 7 divided by 4. So 7 is nothing but equal to value of x. 4 is equal to y by 2. So you are having y by 2 equal to 4. You can calculate the value of y. So y is equal to 4 into 2 equal to 8. So therefore the formula of hydrocarbon is C7H8. Hence the correct option is C. Question number 10. What is the molarity of the solution made by dissolving 10 gram of sodium hydroxide in 100 gram of water? Options are A 2.5 molar, B 5 molar, C 10 molar and D 1.25 molar. Here the correct answer is A, 2.5 molar. So I show the calculation solution. So you know that obviously molarity is equal to number of moles of the substance divided by volume of the solution in a liter. So for that you have to calculate here number of moles of the NaOH as well as volume of the solution in liter you have to calculate. So number of moles of NaOH can be calculated by using the formula mass divided by molar mass. So mass of NaOH is given 10 gram. Molar mass you have to calculate by adding atomic mass of sodium, oxygen and hydrogen. Atomic mass of sodium is 23 plus atomic mass of oxygen is 16. 16 plus 23 plus atomic mass of hydrogen is 1. So 16 plus 23 plus 1 becomes equal to 40. So 10 divided by 40 gives 0.25, that is the number of moles of sodium hydroxide. Next, you have to calculate volume of solution. In liter you have to calculate. So in the question they had given in gram. So you have to convert gram into liter. So for that you use this standard value, basic value. That is 1 gram is equal to 0.001 liter. So if 1 gram is equal to this much, 100 gram is equal to 0.01 into 0.001 into 100 gram, that is equal to 0.1 liter. Then you directly substitute in the molarity formula. So number of moles is 0.25 divided by volume of the solution in liter is 0.1 equal to 2.5 molar. Thank you.